Hi, this video will walk you through Lab 2 where we're looking at the mplabx environment. And in particular, you need to demonstrate a series of tasks to the TA, and we'll just walk through each one of those tasks. So let's open mplab and load in a project. Here's mplab. Now that it's loaded up, we'll go ahead and open a project. You'll need to navigate to the directory where you've placed your project. In my case, this is the location where I downloaded the zip file and unpacked it. Underneath the zip file, we'll need to scroll down to the Chapter 3 directory, and you'll have several projects listed. This is the one that will need mptestword.x, and simply click Open Project. Now that our project's loaded, a double click here will bring up the actual source code and allow us to look through the code. My screen is rather limited in size. I'm sure you'll have a bit more real estate. As we look through that, the first thing that we want to do before really understanding the code is simply compile it and see if we can get it to run. So to do that, I'm going to click on Debug and then debug the project. We'll see a number of compiling messages. Assuming that all goes well, we'll get a launching message. And then in the debugger console, something telling us that our program's running, and you can see the bar here that indicates that things are still happening. And I'll hit the stop button to end our simulation. Notice several things happen there. If we look in this tab, you'll notice that lots of information scrolled by, indicating that our project was successfully compiled, and you see compile messages here. And at the very end of that process, if you look carefully, you'll see a everything completed and build successful message. So that indicates to us that we've started mplab, we've opened the project, and we successfully assembled it and seen the compile or assemble process work correctly. Next, we want to take a look at the program memory window to look at the code behind our program. To do so, let's go to the window menu and take a look at the pick memory views. Here's our program memory window, and that pops it open. And for our purposes, what's important is the address. We want to start at the beginning of our program. This is the end, so I'm going to scroll up a bit until we get to address 200 hex. So here we are. This is address 200 hex, and this is the beginning of our program. Several useful pieces of information there. There's the actual hexadecimal address of the place we are in program memory, an opcode which tells us exactly what instruction, a label, and then a disassembly telling us what these numbers mean in a bit more of a human readable form. That accomplishes the first or second objective on our list. Now let's move on to taking a look at the file registers window to view our program's data. As expected, if we go down to our pick memory views and now look at our file registers, we'll get a list of values. Notice we begin at address 0. That's not what we want. We want to begin at the beginning of the data that we're able to use, which is address 1000. So here's the beginning of the data area that you want to look at, and some of these values, as we take a look at the program, should look familiar. Next, we'd like to open the watch window and add some variables to it. So, as before, we can go down here to the debugging menu. Here's our watches. And this, assuming you have no watches, we can simply type one in. We want to watch a variable called U16I. We also want double click to enter U16J, and so on and so forth. I'll put in U16K. We also wanted to watch some special function registers. In particular, we wanted to watch WREG 0, 1, and 2. I'll type those in. Here you can see I've got WREG 0, 1, and 2, in addition to I, J, and K, are all being watched. And if I look carefully, I can see the value as the value changes. Now let's take a look at exactly what this program is and what we should expect in terms of output from it. So I simply scroll to the top of the program. There's two ways to look at this program. One is simply by reading the text, and this is where we're going to modify code, and the objective overall is to take some C code here, translate that to assembly language, and then work through that process a bit. There's another way to look at it, which is a nicely formatted web version, and I'm going to refer to that as something a bit easier to read. To find that, simply go to the home page of the course, follow the software link, and then we'll go through the examples. And then in that example, notice that there's a link for the assembly language, and that brings us here to the web page we'll look at. So we'd like to translate this C program into assembly. Starting at the beginning, we need to declare the variable u16i. Now this is a 16-bit number, and that means we need to set aside 2 bytes for it. So we start with a bit of syntax. We have to tell it, oh, this is data, by putting in .bss. We'll give it a name, u16i, followed by colon, and then tell it set aside 2 bytes. Likewise for j, we need 2 bytes, and for k, we also need 2 bytes. Now that the data is there, we're ready to start translating our code. Here's the body of the code. Now notice what's happening. This is very important. Here's the C code all grouped up. But what I've been doing is I put one line of C code and follow that immediately by its translation to assembly. A second line of C code followed by its translation. This is the style that you need to follow during the course of this class. So here's our code. First we tell it we're ready to put code in. That's what text means. And then we put in a couple lines that tell it, and this is what I want you to do shortly after reset. Now we're going to follow the same thing. Here is a line of code. Here's the original C program up here. We just want to assign the number 2047 to the variable I. That happens to be 7FF in hexadecimal. So I'll put that as a comment, and then I'm going to place a register assignment. Let me store the number 2047 in W0. Because there's an equal sign on both sides, I'm also going to store the number W0 in the variable U16I. So we go through our typical process, input, output. We're going to move, that is really copy, the number 2047 to W0, and then copy it from W0 out to our desired U16I. And we'll repeat that. Now, next line, we'd like to add 1 to I. In this case, we execute it all in one instruction. So this is input, process, and output. There are no register assignments, so I have no comment above it. For our next line, we proceed as expected. Here's my C code. Here's my register assignment. My register assignment says I need to put I into W0. That's this bit. Or I should say, that's that piece. Next up, my job is to do a similar thing. We want to put W0 into J. So there's my next line. I'm taking W0, copying it to J with the input-output process. To subtract 1 from J, we can use the decrement instruction. Again, there's no register assignments needed. For our last statement, I'd like to make K the sum of J and I. So here's my register assignment. I is in W2, J is in W1. I need to input both of those on the right side of the equals sign. So here you see J going into W1, I going into W2. Now I'm going to do the process, my addition. So I'm going to add W1 plus W2. The answer goes in W0. And now that I've got the answer in W0, it's time to take W0 and copy it out to K. So I take W0 and copy it out to K. Now that our code is done, we have to tell the processor what to do next. So we just put it in a little infinite loop right there. Let's watch that actually happen as we simulate this in the mplabx development environment. So the first thing I'll do is I'm going to click once and place a breakpoint here. So when I go and debug my project, it fires up the debugger. It'll immediately notice the green arrow here, stop at this line, and allow me to watch what's happening. And by watch what's happening, what I mean is I can observe what happens in those watches I've set up. I can also observe what's happening in several other places. Let me make this window a bit bigger. If I wanted to see what's happening in program memory, I'm now at address 29E, and I'm executing this move 7FF to W0. Well, remember that's the same as the number 2047 in decimal. So this is just a retranslation, a more machine-oriented representation. And over in my file registers, I know that I'm expecting the number 7FF to show up wherever U16I is, and it looks like U16I is there at address 1000. Therefore, I would expect this number at address 1000 to change. So let's see that happen, and what we're going to do is execute one line of code. To make this a bit easier, I expanded my screen, and notice when I make it a bit bigger, I get a F8. I can press F8 and it'll execute one line of code. So I'm going to do that. Press the F8 key, or equivalently, click right here, and we're going to watch one line of code, the number 2047 go into W0. And we should see that in a couple places. Number one, down here in my watches, notice this value was red a moment ago, indicating that it's a new value. And if we can, pardon me, let me resize my screen so that's a bit more visible. We notice that the 7FF value is red. That means it just changed. As we execute our next instruction, and I'm going to press the F8 hotkey rather than use the menu up here so I can keep my screen a bit smaller, we would expect U16I to change. I'll scroll up so we can watch that happen. We execute that, and now I has the number 7FF in it. And more than that, this number, the same number, but just not with a nice label on it, is also changed to 7FF. Here in program memory, we've gone down, we've executed this instruction. We're just about to do this instruction, so we can kind of watch that progress happen. Again, I would expect I to go up by 1 as I press F8 one more time, and there it goes, and so on and so forth. This allows you to step sequentially through the entire program. That concludes this demonstration. We've single-stepped the program, we've watched memory locations and watch window locations, and talked about correlating those values. Now it's your turn. Make sure you can go through this on your own and demonstrate that to your teaching assistant. A few additional hints. If you accidentally close some windows you didn't mean to, you can always get them back under the window menu. So for example, we just closed the watch window, and I can pull that back open by just clicking on watches here. Or I also closed this projects menu, and so I can reopen it here. So don't worry about closing things, and feel free, if you find this a bit crowded, you can close things that are no longer in use. Finally, when you're done debugging, make sure to press this stop button, otherwise you'll get several debug sessions running at once, which can be a bit confusing.